This lesson is on dividing polynomials by polynomials. It's actually going to be like long division of polynomials. Recall long division. You've got your divisor and your dividend. The dividend is being divided by the divisor. So let's just recall the long division algorithm. We're going to look at fitting 21 into 23. We're only looking up to here right now, and we're going to put our answer above the 23. So 21 fits into 23 once, and then we can multiply to check how far off we were. We will subtract. 23 minus 21 gives us 2. So that means we were close. Our 2's canceled. Our 3 minus 1 gave us 2. And that's one step of the division algorithm. Once you're here, if you want to continue, you would drop the 3. And now, again, you're going to fit 21 into 23 and place the answer to that above the end of this number. So 21 into 23 goes in once. Again, you multiply 1 times 21, so that's like 1 times 20 and 1 times 1, giving us 21. We can subtract. Our tens column disappears because 2 minus 2 gives us 0, and 3 minus 1 gives us a 2. Now we can drop the next digit, 24. So now we're trying to fit 21 into 24 and placing the answer above the end of this number, which also goes in once. 1 times 21 and then subtract gives us a remainder of 3. So this here is called our quotient. So it goes 21 goes into 2,334 111 times with 3 left over. And this here, 3, is called the remainder. So there was a time where you would have just answered this question as 111 remainder 3. However, another way to represent it would be by going 2,334 divided by 21 was equal to 111 plus 3 out of 21, because 3 has not yet been divided by 21. It was left over. So if we generalize this way of representing our answer, we're going to be looking at this format here. The dividend over the divisor is equal to the quotient plus the remainder over the divisor. Let's translate this into taking polynomials and using the long division algorithm to divide them. You'll notice that I've made a similar example in polynomial form to the one that we just completed on the previous slide. So we're actually taking 2x cubed plus 3x squared plus 3x plus 4, and we're going to be dividing that dividend by 2x plus 1. Take a look at your coefficients that I've chosen. 2x plus 1. What if x was 10? If x was 10, this would be 2 times 10, that's 20, plus 1, that would be like 21. If x was still 10, you'd have 2 in the thousands and 3 in the hundreds, and 3 in the tens, and 4 in the ones, giving us 2,334. So I've made a similar example. You'll notice that the place values are held by the different exponents of the polynomial, and you do need to have every single one. Just like when you write 204, you're making a 0 in the tens column. So in polynomial form, you'd say, well, you have 2 hundreds and 0 tens and 4 ones. So it's going in decreasing polynomial form. So format here is going to make a difference for you, so pay attention to format. Alright, let's apply the exact same routine that we did previously to this example. Now, the only thing is, we no longer have regular numbers like you're used to. We have polynomials. We can still guess, multiply, subtract, drop, and then guess again. We can still do all of that, but there's one difference. We have this second component. So we're trying to basically take something here in this position that we will multiply this polynomial by to land here, and so that when it subtracts, the one column will be gone and the other one will stay. So we're looking to take something times 2x plus 1 to give us something that starts with a 2x cubed plus something. We don't really care about the tail end. We care that the first term cancels with the first term when we subtract later. So what would you multiply 2x by to get 2x cubed? Well, 2 times 1 gives us 2, and x times x squared gives us 2x cubed. So now we're taking x squared and multiplying it by 2x and by 1. And 1x squared times 1 will give you 1x squared. Now you want to subtract this entire item away, so 2x cubed minus 2x cubed is going to give you 0, and 3x squared minus 1x squared, and notice it's a minusing a positive, which is still minusing, will give you positive 2x squared. So this subtraction, you'll notice you need to distribute this negative to both terms. Okay, so that was our remainder there. Now we want to drop the next term, just like here. Drop the next term, you get plus 3x. So now we're looking for something that multiplies by 2x to give you 2x squared. Well, all that's missing there is a positive x. Positive 1x, you could say. You don't need to write the 1. 1x times 2x gives us 2x squared. 1x times 1 gives us positive 1x. Now we want to subtract, just as we did here. You'll notice we still have all the same coefficients. Subtract 2x squared minus 2x squared gives us 0. 3x minus positive 1x gives us positive 2x. So, good. The main goal here is to make sure that the leading term cancels out. That's all you really care about. The rest of it follows. So as long as you're multiplying through for both components of the term, you will be fine. Drop the next digit. That's just hanging out. And now we're looking for something to multiply here by the divisor so that the leading term cancels out. So what could we multiply by 2x to give us 2x? Well, only by 1. So plus 1 times 2x gives us positive 2x. Positive 1 times 1 gives us positive 1. Now we can subtract. You'll notice the signs are changing. 2x minus positive 2x. 0, 4 minus positive 1 is positive 3. Therefore, our quotient is, without these circles, they look a little silly, x squared plus x plus 1. Notice all three coefficients are 1, just like we had in our numbers example, and our remainder is 3. So remember, the answer to this is going to be given as the quotient plus the remainder that is still not yet divided by the divisor. This may seem a little complicated, but let's move on and look at a few more examples of it. Let's take a look at another example. Here we want to divide 8x squared plus 2x minus 3 by 2x minus 1. So let's follow the exact same routine. We have 2 terms going into 3 terms, so we're going to go 2 at a time and write our answer at the end of the second component. However, we're looking for something to multiply by the first term to cancel our first term out in our dividend. So what times 2x will give us 8x squared? You can even write it on the side. What times 2x will give us 8x squared? Well, we will need to have a 4, because 4 times 2 is 8, and we'll need to have an x, because x times x gives us x squared. So let's try that. So if you want to do this on the side, what you're really doing is 4x times 2x minus 1 is equal to, distribute that, 8x squared minus 4x. And that's what we're doing here. You don't need to write it on the side, but that's actually what's happening right here. 4x times 2x gives you 8x squared. 4x times negative 1 gives us negative 4x. Now we can subtract to see what's left over. We need to make sure that the leading term canceled out. If it didn't, try it again. 8x squared minus 8x squared gives you 0. Great. 2 minus negative 4. Now be careful here. You're going 2 minus negative 4x. So that's 2 plus 4, which is positive 6x. Now you want to take down the next term and try something else, so that when it multiplies by 2x, you get 6x. So 2x times what gives us 6x? Well, we need a 3. Positive 3 times 2x will give us positive 6x. And 3 times negative 1 will leave us with a tail end of negative 3. Now when you subtract that, you'll notice that 6x minus 6x is 0, and negative 3 minus negative 3 is negative 3 plus 3 is 0. So, that's nice. No remainder. Well, that means it divided evenly. So our answer is just the quotient. You could technically write 0 over 2x minus 1, but you don't need it because that's essentially adding 0. So there's our answer. Let's take a look at this example. It's a little different. You've got 27 minus x cubed and 3 minus x. What is missing here? This doesn't look like a polynomial in decreasing exponential form. And our polynomials need to be in decreasing exponential form if we want to divide them, because we need to have every single position filled in. So a numerical example would be, say, instead of writing 2001, filling in the missing place values with 0, we wrote 21. Well, that wouldn't really work, would it? Because 21 means something completely different than 2001. So we want to start with the highest degree and rearrange each one so that everything is written in order. Let's rewrite it. That would be negative x cubed. Do we have an x squared term? Why no, it's missing. So you can put a 0 in front of it. Do we have an x term? That one's also missing. So we should add 0x so that we hold the place value, because long division by its nature assumes place value and requires it. And then we have a positive 27 at the end. This polynomial here can also be written x to the power of 1 is a higher degree than x to the power of 0, so we want to write this as negative x plus 3. That way we can apply long division and be sure that all our columns are lining up. So, important, remember to always fill in missing terms with coefficients of 0 to make sure that you have a decreasing order of exponents. So let's try it out. We're going to take negative x cubed plus 0x squared plus 0x plus 27 and divide it by negative x plus 3. So we think first, what times negative x gives us negative x cubed? Well, negative times a positive will give us a negative, and x squared, 1 times 1, so x squared times negative x gives us negative x cubed. X squared times positive 3 gives us positive 3x squared. Notice how when I multiplied this component by the 3, I was left with an x squared, meaning I needed to have x squares here in order to cancel. If you had written 27 here, you wouldn't be able to collect those like terms. And so that is essentially the reason for filling in the missing terms with zeros. Let's continue. We're going to subtract. 0 minus positive 3x squared gives us negative 3x squared. We can drop the next digit plus 0x. And we are now thinking, what times negative x gives us negative 3x squared? And that would be a positive 3x. 3x times negative x gives us negative 3x squared. 3x times 3 follows along and gives us positive 9x. We're going to now subtract, and we're left with 0 minus positive 9, which gives us negative 9x. Now we can drop the next term, plus 27, and we think, what times negative x gives us negative 9x? It needs to be positive to keep the negative, and we need a 9. 9 times negative x gives us negative 9x. 9 times positive 3 gives us positive 27. So when we subtract, we are left with 27 minus positive 27 with the remainder of 0. Great! No remainder means that our answer is just our quotient, which is x squared plus 3x plus 9. Here's another example. Say the area of a rectangular object is this much, x squared minus 2x minus 24 inches squared, and the width is x plus 4 inches. What's the height? Well, if we have the area given, and we have one side given, side, S for side, then the other side would be taken by the area divided by the other side, right? Because A over S times S would give you A back again. You could try that with 2 and 3. 2 by 3 is 6 square units. So if you didn't know one of these, you go 6 divided by 3 to get the other one. So we know you need to divide. Okay, let's take x squared minus 2x minus 24 and divide it by x plus 4. Similarly, what times x gives us x squared? X. X times x gives us x squared. X times 4 gives us positive 4x. Minus that. So x squared minus x squared, and negative 2x minus positive 4x. So negative 2 minus 4 is negative 6x. Drop the next digit. Now we're trying to make it a negative 6x. So that's going to give us a negative 6, because negative 6 times x gives us negative 6x. Negative 6 times positive 4 gives us negative 24. And we actually have the exact same terms, which both cancel out, giving us 0. Therefore, it's following something that we expected, a nice answer for the other side. So if one side is x plus 4 inches, the other side would have to be x minus 6 inches in order for x plus 4 times x minus 6 to give us x squared minus 2x minus 24 square inches. Notice if you actually checked your work and multiplied it out, I'll let you check for yourself, but that would give you that back again, wouldn't it? So the answer is x minus 6 inches.